Hello, and welcome to a little video for the Integrated 1 Core Final second semester review. This is going to be a long video, so just be prepared. And if I make a mistake, I'm just going to correct it and not restart the video. So just a warning ahead of time. Number 1. What is the common ratio of the sequence as follows? In order to find R, the common ratio, what we do is we do term 2 divided by term 1. Well, in this case, term 2 is negative 2 divided by our first term, which is 4. Negative 2 divided by 4 gives us an answer of negative 1/2, or you may have gotten it as negative 0.5 on your calculators. Number 2. Which functions have a constant multiplier less than 3? That means, where is our pattern less than 3? All right, well, let's see. Just like in number 1, we're going to divide our second term divided by our first term. So in letter A, 16 divided by 32 is 1/2. 1/2 is less than 3, so letter A is our option. Letter B, the constant multiplier is 2. Yay, that's an answer. In letter C, the constant multiplier is 3. 3 is not less than 3. Letter D, let's see what the pattern is. Second term divided by first term is 2, which is also a less than 3. Number 3 asks us to write this function after a horizontal translation 6 units to the right. The first thing I'm going to do is I'm going to rewrite this as f prime of x, because that means it's transformed. 2 times 4 to the x stays 2 times 4 to the x, and in order to translate our function 6 units to the right, we're going to subtract 6 up here by our exponent. Number 4. The graph f of x equals 3 to the power of x is shown on the right. Here it is. Oh, let's let that load, okay. Which graph below shows the function f of x minus 1? Well, this minus 1 means down 1. So take a look at your options. Which graph, A, B, C, or D, looks like we took this original one on the right and moved it down 1? Hopefully, you thought it was C. All right, let's flip the page. Number 5. The equation f of t equals 12,450 times 1.42 to the power of t models annual tuition at a private school over time t. By what percent does the tuition increase each year? In order to figure that out, we need to look inside those parentheses. And inside the parentheses, we have 1.42. Now what that really is 1 plus 0.42. This decimal right here tells us the percent. In order to turn a decimal into a percent, we multiply the decimal times 100, and we get 42%. Number 6. Louis deposits $300 into a compound interest account paying 5% annual interest. Write the function. All right. First of all, our function comes like this. F of t equals a times 1 plus r to the power of t. A is our original price. Our r is the interest in decimal form, and then t is time. All right, so we get 300, because that's our starting point. And then 1 plus 5% as a decimal is 0.05. In order to go from percent to decimal, we do the opposite of what I did in number 5, and we're going to divide by 100. That's how I got 0.05. Number 7. Brenda deposited $345 into an account that earns 3.25% compound interest. how much will her account be after 5 years? Here's the formula that we're going to be filling in. It starts with P of t. Oh, I'm going to rewrite that. That did not turn out how I felt I was going to write it. There we go. P of t. P with the 0 is the same thing as A. It's our original price. So, 345. 1 plus, our R is our rate, 3.25 as a decimal is 0.0325. And our time here is 5 years. So it's to the power of 5. I'm going to put this whole part into my calculator. And I get that after 5 years, Brenda has $404.83. Number 8. The graph represents an exponential function that models the relationship between the temperature of a cooling beverage and the time in minutes. About how many minutes after the beverage started cooling will its temperature be at 90 degrees Fahrenheit? All right, well, let's zoom in here because I can. This is 90. So let's see, where does 90 hit? Ooh, looks like it's right here, which is, ooh, you know what? It looks like about 9.5 minutes. So I'm going to say 9. Oh, I wanted to use black. There we go. 9.5 minutes. You could have also said between 9 and 10. So we could also say between 9 and 10 minutes. Fantastic. Number 9. The number of crickets on the school campus is decreasing exponentially by 2.25% monthly. The number of crickets initially was 3,500. Write an equation that models the decrease. All right, let's do it with f of x. We start with the original number of crickets, which is 3,500. Let's write that down. And then we are decreasing, so it's 1 minus. Our percent is 2.25, so when I divide that by 100, I get 0.0225. And then I'm not given any specific time, so I'm going to just call it x. We could have done it with t, but I felt like doing x this time. All right, let's flip the page. Next unit. Which diagram shows the translation t g of h x equals x prime? So, what this is asking us is, I'm just going to write this in English. Translate x, the distance, and direction of GH. Okay, so let's see which one of these gives us that translation of x to become x prime, the distance and direction of GH. All right, in letter A, GH goes this way, x to x prime goes like this. Although it looks like it's the same distance, it's not the same direction. Letter B, GH goes like this, x to x prime goes in the complete opposite direction. Letter C, G to H, x to x prime, too short. And then let's take a look at letter D, G to H, x to x prime. Same distance, same direction. Number 11, which diagram is an example of isometry? Well, isometry is when the shape moves, but it keeps, or reflects, but keeps the same size and same shape. Take a look at the options. Which one do you think is an example of keeping the same size and shape? Hopefully you decided it's letter C. Number 12, reflect these images. Now the way that I like to do it on my tablet, especially without any of those wonderful utensils that you can have in class, is I measure the distance between each letter and the line of reflection, which is the middle. And then I'm going to quite literally copy and paste, if it lets me. It usually does. Do you want to let me? There we go. I'm going to copy and paste it directly across that line, because reflections are mirror images. And I'm going to call this B prime. Next, I'm going to do the same thing to C. I'm going to connect C to the line of reflection. I'm going to select that same distance, and I'm going to move it over to the other side of the line. And I'm going to call that C prime. And I'm going to do the same thing with letter A. Oh, there we go. There we go. That's about right. Oh no, it changed colors. Undo that change color. Yay, purple. Alright, this is A prime. And I'm going to connect the triangle as best as I can. I'm going to do the same thing with letter B and the point B. I'm going to connect the line to, or I'm going to connect point B to the line of reflection and measure that same distance on the other side. There's point B prime. Alright, mirror images. Onwards we go to the next page. Which point is the center of rotation for the figures shown? Alright, this is really a visual thing. Which of the letters do you think, A, B, C, or D, is the middle for turning these triangles around? Like this. Hopefully you thought it was letter A, because it is. That one's right in the middle. Alright. Number 14, which diagram shows the rotation RC negative 90 ABCD equals A prime at B prime at C prime at D prime? Now what this is telling or asking us to do is do a negative 90-degree rotation. Well, negative 90 is clockwise 90 degrees. Now remember, 90 degrees is a nice little L shape. Clockwise, let's draw a clock. 12, 9, 6, 3. Clockwise goes with the clock. So what I like to do is I just pick one letter that's labeled, and I see how does it end up to the prime. So in letter A, well, I guess for all of them, let's just do A's. When I do this by hand, I like to connect A to the center, and then I'm going to connect it to the prime. So it looks like from A to A prime, I'm going this way, which is not clockwise. That's actually counterclockwise. Here, from A to the center, oh, that's a straight line. That's not even 90 degrees. That's 180. I'm not even going to bother with that. Letter C. Now remember, it could be no diagram, so we got to try letter C. A connects to the middle, goes to A prime. Okay, that's 90 degrees. Good. And it looks like, yes, we are going clockwise. Number 15. What is the rotational symmetry of this figure? So, how much do I need to rotate this trapezoid for it to end up exactly the same? Well, it's 360. There's no real rotational symmetry here. It would have to go all the way around to end up to being the same image. Number 16, let's draw the lines of symmetry for this regular pentagon. Lines of symmetry are lines that split an image into perfect mirror halves. So they're exactly the same when we split it in half. Let's start. I got one here. I suggest as you're doing this, you're turning your paper because that's how I did it when I did the answer key. I got one more here. I got another line here. I got a fourth line there and a fifth line here. So there are 5 lines of symmetry for this regular pentagon. Next page. Which sequence of transformation will carry the given pre-image to the image showed in dashed lines? So I want to end up from here over there. Now, it looks like we're just to me, before even looking at the options, it looks like I'm rotating. It looks like I'm going clockwise in the rotation. And it looks like I'm moving to the right. It doesn't look like I'm reflecting because this image doesn't end up being kind of a mirror image of itself. So I'm going to say no to this reflect one. Do I have any other reflects? And no to this reflect. All right. Rotate -90, so that's clockwise, about D, then translate to the right. That works. This one says translate to the right and then rotate. That also works. So for number 17, B and C both work. All right, next unit. Let's match the postulate to the following relationships. All right, let's take a look. Let's start with the postulates. Oh, I hate when I do that. There we go. Sometimes I zoom in too hard or out, or zoom in too much, and then OneNote just does this to me. That's rude. All right, I did it again. That was not zoomed in too much. That's bogus. Come on, buddy. All right. What I'm going to do is I'm just going to start off with the postulate. And I'm going to, actually, first of all, let me number these because I'm just going to save myself some time and handwriting if I just write some numbers. Okay. Now this first image has 2 angles marked and it's a straight line. So the postulate is not angle addition. Did you see that? I did 6, 8, 7. It's not angle addition. It's specifically a linear pair because those 2 angles, yes, they're being added together, but they create a line. So the postulate is 8, linear pair postulate. And the statement that goes with it is 2 angles being added together. So that gives me either 1 or 3. And this specifically creates a straight line, which is statement number 3 because it adds up to 180. In this image, I see 2 angles across from each other, and they're labeled the same way. So these are going to use the statement number 4 because those are 2 angles equal to each other. They're congruent to each other. And the postulate is vertical angles. The way I remember this postulate is that these angles, when they face each other, they create 2 V's. All right. Next one, we got a line segment. And I think picking the postulate that matches it is easiest. It's the only one that has the segment addition, so that's 5. For the statement, I can only pick the one that has line segments in it, which is statement number 2. Don't really have many options left here, but in this image we have just angles. This is angle addition, and a 1 is going to match it as a statement. I should have labeled this, but it should have been kind of like this and like this. And then this one should have been like this and like this. Okay. Anyways, next page 19. State the congruencies of the shape. Well, I see 2 congruencies. I see 2 sides that are congruent and 2 angles. Let's start with the sides. I see this side right here. That's called E. You see that? I said E and I wrote a G. It's called EG. Put a little hat on top. And it matches with this side here, which is HG. Next, I see the 2 right angles. You see these 2 little corners? These are 2 right angles. I'm going to use 3 letters to label it. This one on the left is EFG, angle EFG. And the one on the right is HIG, angle HIG. Remember, the vertex, or that middle of the angle, needs to be the letter in the middle. Number 20. State what additional information is required to know that the triangles are congruent for the reason given. The reason given for number 20 is side angle side, SAS. Well, it looks like we already have a side on both. We have an angle for both, which means they are both missing another side. We're missing CA on the triangle on the left and LJ in the triangle on the right. 21. Which congruence theorem can best express the relationship showing the triangles below are congruent? Let's see what each triangle has. I see an angle with one arc on both triangles. I see a double arc. And I also see a side. Well, if we have two angles and a side, is it an angle side angle sandwich? It sure is. This is going to be angle side angle. 22. The image in this figure was formed by reflecting triangle LXP over the x-axis. That means a mirror image was created there. What congruence statement describes these triangles? Looks like I got a bunch of angles. So before I start checking what's right and what's not right, I'm going to mark them and see which would be the reflections of each other. Just like I did in when I was creating those reflections. What number was it? It was number 12. So if I connected P to the x-axis and kept going, it would connect to W. If I connected L to the x-axis and kept going, it connects to T, and that means X would be the same as letter D. So let's see which one of these works. Letter A says angle L is congruent to angle D. No. D